Greetings, fellow puzzle enthusiasts. In today's tutorial, we are embarking on a captivating mathematical journey to explore the intricate world of squares within a 12 by 12 chessboard. We won't just count them, we'll also delve into some fascinating mathematical principles along the way. As you've gathered from the title, our quest is to determine how many squares of all sizes resides within a 12 by 12 chessboard. Without further ado, let's dive into it. To begin, let's establish the fundamentals. The problem must be determined by the number of squares in a 12 by 12 size checkboard. With the checkboard as our condition, we must solve and find the answer by using our mathematical logic, in which this problem is an inductive reasoning problem with its continuous patterns and a specific example at the start. As you're aware, a chessboard comprises 12 vertical columns and 12 horizontal rows. This configuration transforms the chessboard into a square grid measuring 12 by 12. Let's start by counting the 1 by 1 squares, the very essence of our board. There are 12 by 12 of these tiny squares, resulting in a total of 144. You can see the 1 by 1 squares highlighted on our board. But what about larger squares? That's where our journey becomes truly fascinating. Now let's venture into the realm of 2 by 2 squares. To tally this, we scrutinize the rows and columns. We discover that there are 11 rows and 11 columns of 2 by 2 squares, summing up to 121 of these larger squares. These 2 by 2 squares form a visual pattern on our chessboard. However, we are not stopping here. We are about to extend our pattern to even larger squares. Next in line are the 3 by 3 squares. Here, we have 10 rows and 10 columns, resulting in a total of 100. The pattern persists with 4 by 4 squares, with 9 rows and 9 columns dedicated to them. We count 81 squares. The pattern continues as we explore 5 by 5 squares, with 8 rows and 8 columns in play. Our count reveals a total of 64 squares.
Stepping further, we encounter 6 by 6 squares. There are 7 rows and 7 columns, so 7 squared, tallying to 49 in total. The next pattern involves 7 by 7 squares with 6 rows and 6 columns. In the equation, in which 6 squared, we find a total of 36 squares. We persist in our exploration, calculating squares of size 8 by 8. There are 5 rows and 5 columns, therefore 5 squared, equating to a total of 25 squares. Continuing onward, we tackle 9 by 9 squares, presenting 4 rows and 4 columns, therefore 4 squared. We count 16 squares. The pattern endures as we investigate 10 by 10 squares with 3 rows and 3 columns, contributing a total of 3 squared. We discover 9 squares in total. Our journey to the pattern extends to 11 by 11 squares. Therefore, this involves 2 rows and 2 columns, thus 2 squared, resulting in 4 squares. We reach the grand culmination with the 12 by 12 squares. In this case, there's only 1 row and 1 column, therefore 1 squared, yielding a total of 1 square.
To ascertain our grand total, we simply sum the squares of all sizes. So 144 squares plus 121 squares, 100 squares plus 81 squares plus 64 squares plus 49 squares plus 36 squares plus 25 squares, 16 squares plus 9 squares, 4 squares, and lastly 1 square. So adding up these figures, we arrive at the astonishing revelation that the total number of squares of all sizes on a 12 by 12 chessboard or checkboard is 650. Before we conclude, let's take a moment to appreciate the beauty of this puzzle. The number of squares of each size diminishes by 1 as we progress from smaller squares to larger ones. This phenomenon arises from the fact that for any size, there is one less square in each dimension. It is a captivating example of combinatorics. Wraps up our journey through the realm of squares on a 12 by 12 chessboard. I trust you found this tutorial both informative and engaging. Thank you for joining us, and until our next adventure, keep exploring the fascinating world of mathematics. Thank you.